In section 5.5, we're looking at negative exponents and scientific notation. Our learning objectives are to simplify expressions containing negative exponents, use all the rules and definitions for exponents to simplify exponential expressions, write numbers in scientific notation, convert numbers from scientific notation to standard form, and to perform operations on numbers written in scientific notation. Let's simplify each expression. We're going to write each result using positive exponents only. So quick review, the negative exponent rule. If b is any real number other than 0 and n is a natural number, then b to the negative n power can be written as 1 over b to the positive n power. So that's one way we can deal with negative exponents is to make them positive. If there's a negative exponent in the numerator, you bring it to the denominator and that exponent becomes positive. If there's a negative exponent in the denominator, you can move that to the numerator and that exponent becomes positive. Let's begin with the first example, 3 to the negative 2 power. This is the same thing as 1 over 3 to the second power. So we can write the result as 1 over 3 to the second power, or we can evaluate this, simplify it as 1 over 3 to the second power as 1/9. Let's look at this second example, 8 times a to the negative third power. Now the 8 has its own exponent, which you don't typically write, but we understand that that number 8 is 8 to the first power, which is a positive exponent. So we're going to leave 8 just where it is, but that a to the negative 3, we're going to move that so that we can write it as a positive exponent. So then we can leave the 8 in the numerator, and then a to the negative 3, when moved to the denominator, becomes a to the positive 3. So that is how we would write our final answer, 8 divided by a to the third. Let's look at the example C. We have x to the negative 4 divided by y to the negative 2. We can rewrite this by moving these terms, and those exponents will change signs. So the x to the negative 4 in the numerator will become x to the positive 4 in the denominator, and y to the negative 3 in the denominator will become y to the positive 3 in the denominator. So our answer here is now y to the third divided by x to the fourth. In part D, we have 4 to the negative 2 plus 4 to the 0 power. 4 to the negative 2 can be written with a positive exponent by writing 4 to the positive 2 in the denominator. And we remember from our previous rules of exponents that any number raised to the 0 power is 1. So 4 to the 0 power is 1. We can rewrite this as 1 over 4 to the second power, which is 1 over 16 plus 1. And you can add those together by getting a common denominator. You can write this as 1 over 16 plus 1, which is the same thing as 16 over 16. And then you can add those fractions together because you have the same denominator, so that our result is 17 over 16. Let's simplify each expression and write each result using positive exponents only. We're combining the properties of exponents from the previous section with the negative exponent property from this section. Here we have in part a to the negative 6 times a to the negative third times a to the negative 2. Using the product property of exponents, we know that we can add those exponents together because the bases are the same. So the exponents are negative 6 plus negative 3 plus this exponent for just a is 1 plus a negative 2. When you add those exponents together, you get a to the negative 10. Now we want to make sure we write our answer using positive exponents. So in order to make this a positive exponent, we need to write it as a fraction with a 1 in the numerator and a to the 10th in the denominator. So our answer is 1 divided by a to the 10th power. In example B, we're going to use the power property. So we have 2 to the third power. We want to raise this quantity to the third power, so it's going to be 2 to the third times x to the fourth to the third power divided by x to the 15th power. Let's simplify this. We know 2 to the third is 8, and x to the fourth to the third power, this is a power to a power, So we multiply those exponents. 4 times 3 to get 12. So in the numerator we have 8x to the 12th, and then in the denominator we have x to the 15th. Now we're going to use the quotient property of exponents, where if we have the bases that are the same and it's a quotient, then we subtract those exponents. So we can write this as 8 times x, since the x's have the same base. We subtract those exponents, 12 minus 15. So then we have 8 times x to the negative 3 power, but we want to write our result using positive exponents, so we can keep that 8 in the numerator and x to the third in the denominator. So our answer is 8 divided by x to the third. Okay, let's continue with part C, where we have the entire quantity x to the negative 2 y to the eighth all raised to the negative 2 power. So we want to share that exponent, so we can write this as x to the negative 2 to the negative 2 power and y to the eighth to the negative 2 power. Using a power to a power rule, we can multiply those exponents together to get x to the negative 2 times negative 2, which is x to the fourth power, and y to the 8 times negative 2, which is y to the negative 16th power. We want to write our answer using only positive exponents, so we need to write this as a fraction, where x to the fourth stays in the numerator because the exponent is positive, and the y to the 16th moves to the denominator so that it becomes positive. Our final answer, x to the fourth divided by y to the 16th. Okay, for part D, we're going to simplify this. Look first at the coefficients, negative 6 and negative 12. We can simplify that fraction, negative 6 divided by negative 12, as a positive 1/2. Now let's look at the x values. We have x to the second in the numerator and x to the fifth in the denominator. By using the quotient rule for exponents, we can subtract the exponents. So it's x to the 2 minus 5. And we have a y to the negative 3 in the numerator, y to the negative 6 in the denominator. We can write that as y to the negative 3 minus negative 6. That's using the quotient rule for exponents. Now when we simplify those exponents, we have 1/2, and x to the power of 2 minus 5 would be x to the negative 3 power. And y to the negative 3 minus a negative 6, that minus a negative becomes a positive, so it's y to the positive 3 power. We write our final answer using only positive exponents. So we're going to write this as a fraction with the 2 in the denominator, that x to the negative 3, we want to move that to the denominator so it's an x to the positive 3, and y to the positive 3 power is going to stay in the numerator. So our answer is y to the third divided by 2x to the third. Okay, let's continue on with these examples. We're going to use the power rule first. In the numerator, we have m squared times the quantity of m to the negative 4 to the negative 2 power, and in the denominator, we have m to the negative 2 to the fifth power. So let's leave m to the second power alone for now, and then using the power to a power rule, m to the negative 4 to the negative 2 power, we're going to multiply those exponents together to get m to the eighth power. And in the denominator, the m to the negative 2 to the fifth power, we're going to multiply negative 2 and 5 together to get m to the negative 10th power in the denominator. Now we can move that negative exponent to the numerator, and we can write this as m to the second, m to the eighth, and that m to the negative 10 in the denominator we can write as m to the positive 10. Now we can use the product property of exponents and add those exponents together. So it's going to be m to the 2 plus 8 plus 10. Since all the bases are the same and you're multiplying, you add those exponents together. So this can be written as m to the 20th power. Let's look at example F. We're going to make sure that we raise the numerator to the negative third power and the denominator to the negative third power. And we're going to have to do several steps here. In the numerator, we can raise each one of those terms to the negative 3 power. So that's going to look like a 3 to the negative 3 power, the x to the negative 3, and the y to the fifth, we're also going to raise that to the negative 3 power. In the denominator, I'm going to raise all of the terms in the denominator to the negative 3 power, so that's 2 to the negative 3, x to the fourth to the negative 3 power, and y to the seventh to the negative 3 power. Now I can rewrite this so that I can write this as the 3 to the negative 3, I can put that in the denominator to make it 3 to the positive 3 power. The x to the negative 3, I can move that to the denominator to make it a x to the positive 3 power. The power y to the 5th to the negative 3rd power, that's the same thing as y to the negative 15 power, but we can write that as y to the 15th power in the denominator. In the denominator, we have 2 to the negative 3 power, which is 2 to the positive 3 power if we move it to the numerator. X to the 4th to the negative 3rd power, that's x to the negative 12th power, but we're going to move it to the numerator to get x to the positive 12. And then y to the 7th to the negative 3rd power, that's y to the negative 21 power, but we're going to write it as y to the 21st power in the numerator with a positive exponent. Now we can simplify this. The 2 to the 3rd is 8. And then the x terms, we have so for the x terms, we have an x to the 12th in the numerator and an x to the 3rd in the denominator. We need to subtract those exponents, so it's going to be x to the 12 minus 3. The y, we have a y to the 21st in the numerator and a y to the 15th in the denominator, and we want to subtract those as well, 21 minus 15. The 3 to the 3rd in the denominator, we can write as 3 to the 3rd, which is 27. Now let's simplify this, and we get a fraction with 8x to the 12 minus 3, or 8x to the 9th power, and y to the 21 minus 15, which is y to the 6th power, divided by 27. And in this case, we can see that all of our exponents are positive. So our final answer, 8x to the 9th, y to the 6th, all divided by 27. In example G, we have this entire quantity of 3a to the negative 3rd b to the negative 2 divided by 6a to the negative 2 b to the negative 5. The entire quantity is raised to the 0 power. And we learned in the previous section that any number or expression raised to the 0 power is going to equal 1. So this is, by that property, our final answer is 1. And if you were to work this out by distributing that 0 exponent to all of those, you would see that you would get 3 to the 0, which is 1. A to the negative 3 times 0 is a to the 0, which is also 1. So all of those terms, if you were to share that exponent with the numerator and the denominator, it would all end up as 1. All right, in example H, we have the quantity negative 2r to the negative 3s to the negative 2 times t times the quantity negative 5t to the negative 4. Let's go ahead and multiply those together, and then we can simplify by making any negative exponents positive. So let's begin with multiplying the coefficients. Negative 2 times negative 5 is a positive 10. It's going to be r to the negative 3, s to the negative 2, and then we're going to multiply these t's together, t times t to the negative 4. Well, if those bases are the same, then you're going to add those exponents together, and that's a t to the 1st power, so it's going to be 1 plus a negative 4. Now let's simplify this. We have 10r to the negative 3, s to the negative 2 times t to the negative 3 power. 1 plus negative 4 is negative 3. We can then write our answer using only positive exponents if we write it as a fraction, where in the numerator we have 10, and in the denominator the r to the negative 3 becomes r to the positive 3, s to the negative 2 becomes s to the positive 2, and t to the negative 3 becomes t to the positive 3. Final answer, 10 divided by r to the 3rd, s squared, t to the 3rd. In these examples, we want to convert the following numbers in standard form to scientific notation. The number 5.5 times 10 to the 12th is written in a form called scientific notation. A number in scientific notation is expressed as a number greater than or equal to 1 and less than 10 multiplied by some power of 10. It is customary to use the multiplication symbol x rather than the dot in scientific notation. To write a number in scientific notation, you're going to move the decimal place until you get to a number that is greater than or equal to 1 and less than 10. and then count how many times you move the decimal point, and you're going to multiply 10 by that power. To begin with, we start with 83,000. The decimal point would be at the end, and we're going to move the decimal place 1, 2, 3, 4 places until we get to the number 8.3. And then we're going to multiply that by 10 to the 1, 2, 3, 4 power. 10 to the 4th power is 10,000. So 8.3 times 10,000 is 83,000. Let's take the number 1,250,000 and write it in scientific notation. You're going to move the decimal place over 1, 2, 3, 4, 5, 6 places so that we get the number 1.25 times 10 to the 6th power. Since 10 to the 6th power is 1 million, 1,250,000 can be written as 1.25 times 10 to the 6th power. We can also write very small numbers in scientific notation by moving the decimal place to the right until we get to a number that is greater than or equal to 1 and less than 10. So let's move this decimal place for 0.000154. We move that decimal place 1, 2, 3, 4 places until we get to the number 1.54, and we're going to multiply by 10 to the negative 4 power, since 10 to the negative 4 power is 1/1000th. 1/10,000th. So we can write 0.000154 as 1.54 times 10 to the negative 4 power. The number 0.0000689 can be written in scientific notation by moving the decimal place 1, 2, 3, 4, 5, 6 places so that we get the number 6.89 times 10 to the negative 6. When you're writing numbers in scientific notation, the 10 to the positive powers are large numbers, while 10 to the negative powers are very small numbers. Let's convert the following numbers in scientific notation to standard form. Let's start with 1.03 times 10 to the 6th power. We write 1.03, and we're going to move that decimal place 6 places to the right. 1, 2, 3, 4, 5, 6. We're going to fill in any blanks with zeros. So we can write 1.03 times 10 to the 6th as 1,030,000. 8.7 times 10 to the negative 5th power, we write 8.7, and then in this case the 10 to the negative 5 power, we're going to move that decimal place 5 places to the left. 1, 2, 3, 4, 5. Fill in any blanks with zeros. So 8.7 times 10 to the 5th is equal to 0.000087. 6.003 times 10 to the 10th can be written in standard notation by moving that decimal place over 10 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fill in the blanks with zeros. So this number is written as 60,030,000,000. The number 2.02 times 10 to the negative 3 power can be written in standard form by beginning with 2.02 and moving that decimal place to the left 1, 2, 3 places, filling in the blanks with zeros to get the number 0.00202. Now we will multiply 6 times 10 to the 5th times 9 times 10 to the negative 9 power. We are going to multiply the 6 and 9 together to get 54. And the 10 to the 5th and 10 to the negative 9, we're going to use the product rule for exponents, where the bases are the same. 10 to the 5th times 10 to the negative 9. We're going to add those exponents together to get 54 times 10 to the 5 plus negative 9. 54 times 10 to the negative 4 power. Now it's typical to write the number in scientific notation as a number between 1 and 10. So we need to move this decimal place over 1 unit. And that's the same thing as multiplying by 10. Moving the decimal place over is the same as multiplying by 10. So we can write this number as 5.4 times 10 to the negative 3 power.
I'm the one who's actually...
If you're using a calculator multiplying these numbers together, you'll notice that you get 0.0054 as your answer, and you can convert that to scientific notation by moving this decimal place over 3 digits to get the number 5.4 times 10 to the negative 3. Let's multiply 15 times 10 to the third divided by 5 times 10 to the negative 2. We can divide 15 divided by 5 times 10 to the third divided by 10 to the negative 2. Using the quotient rule for exponents, we can write this as 10 to the 3 minus the negative 2. Simplifying this, we get 3 times 10 to the 5th power. If you're doing this on your calculator, you get 300,000 for your answer, and you can write that number in scientific notation as 3 times 10 to the 5th power.